Okay, so we have everything ready. SAS is switched on, throttle's up, and we are a go. So yeah, speed looks good. The first fuel boosters are almost done. Oh, that was close. Okay, start turning very slightly. These fuel boosters go. That's a pretty cool drop. Okay, I'm going to start slowly turning to the right. The ship lets me, which at this point it's not really. If I turn on the other engine with a bit slower throttle, that might assist me in a turn. Let's do that. Yep, there we go. So yeah, the reaction wheels, or this reaction wheel isn't that strong, so it's not quite giving me the turn that I want. Oh, there it is now. And let's start accelerating for the forwards. Oh, where's this taking me? I'm well off in the wrong direction. Okay, let's have a look. Apoapsis is a bit steep, but it's not the end of the world. Ideally, I'd prefer this to be a bit longer, but that's okay. So this is a bit longer and this is not quite as high. Let's see how we're looking. That's pretty good. So I'm higher than I need to be, but that's okay. It's not wasting too much energy. What I might do actually is cut the engine for a moment, now that I am in space. Okay, I'm T-minus 1 minute away from my apoapsis. Straighten myself up. I might just keep it going actually. Keep the engine going. Just I don't want to get too high of an orbit, but it's not going to be too high. It's not going to be that high anyway. Might cut it again in just a second. Yeah, I don't really want to go over the 100,000. It doesn't really matter, but I don't want to waste too much energy. I don't have that much left. So I hope it will bring me back. It'll get me to the moon and back. We'll see. Okay, one thing we're going to be using for going to the moon is flight planning. I unlocked that when I was you had to unlock that in the space missions place and the tracking station. What that does essentially, so like if I mark here, for example, my apoapsis and add maneuver, I can drag this, and it'll give me an estimate how much power I need to reach this area if I was launching from this part. So I don't need to for now, but I'll be showing you that later, very shortly actually. I need to boost more now, so I'm just going to do that first. Hopefully I'll be reaching an orbit soon. Not with this fuel booster anyway, that's okay. Let's go. This will get me to orbit very soon. And there we go, that's our orbit. So 93 on that side, 70 on that side, perfect, I'm in space. So yeah, if I want to figure out, if I want to make an educate or a better flight plan, because at the moment, like so far, we've been kind of eyeballing it or guessing how much fuel we need and stuff like that. But if I'm making a bigger plan, so for example, if I want to go to the moon, I will be using the flight planner. To use the flight planner, I just click on an area of where I'm going to be flying from. So in this case, my ship is going around Kerbin this way around. Okay, so if I wanted to, let's say, fly or make a maneuver in whatever distance this is, a few minutes away, click on that, I could add maneuver. And it tells me how long away that is, so that's t minus 3 minutes and 22 seconds till I'd get there. So if I was add to maneuver, and you've all these different symbols on it. Two that we know already is this one here, which means in the direction that we're facing, so like the one we've got in our nav ball, direction that we're going in, and that's the opposite direction of what we're going in. So if I was to move that, pull that, it'll start moving outwards on your map. So I could do that, for example, if I want to know, okay, I want to reach 3 million miles above Earth. Okay, that's if I was to launch from here to get to there, it would take me 694 meters per second, which is a burn time of 18 seconds. Okay, with the current engine that I have, that means 18 seconds with the current engine that I've got unlocked, but that would be using full throttle, or it should be using full throttle. I'm not sure if I've calculated right, but usually that tells you the burn time with full throttle. Or maybe even just the last setting you had, but usually you're burning in full throttle, so it would show, yeah, that'll be the full throttle till I get to there. Now what you want to do when it comes to a node, so the way it's calculating, so when I've done that, I've calculated from there to get all the way out to here, and it's calculated, this is the speed that I need, but that's, so, but the way the nodes are working is it's calculated in such a way, this is the speed I'd need from this point to there, but that's exactly from that point, so it would be immediate speed would be that. Now I can't achieve that, of course, so what I don't want to do, so my node, I'll reach that node in 1.5 minutes. But I don't want to start this launch on the dot at 1.5 minutes. What I want to do is I want to take my burn time and half it, so this in this case 18 seconds. Take the 18 seconds and half it, so it would be 9 seconds. So when I see my node, it says t minus 1 minute and 14 seconds. I'd want to start the burn, in this case, 9 seconds, or at t minus 9 seconds, and then burn all the way past the node itself into 9 seconds past, or so t plus 9 seconds. Okay, so you want to split your burn time. Now, just to go in here, it wouldn't matter that much because it's only 18-second burn, but if you're going to different planets, for example, you'll sometimes have a burn of 2 minutes, 3 minutes, or depending on what distance you're doing. And if you're pinpointing at a planet, which is, as you can see here, if I scroll out, you can actually see the planets. Now, if I'm trying to aim for Eve, for example, being off by a few seconds can really mess up your trajectory. So what you want to do is you want to make sure you halve your burn time. So in this case, 18 seconds, so 9 seconds, and you want to then start the burn 9 seconds, or so t minus 9 seconds, and keep the burn going until 9 or t plus 9 seconds. All right. Because if I start later on, it will not bring me to this point. If I was to start later on, this point would probably be a bit slightly over here. In this case, it wouldn't make much of a difference. But if you're going for a longer burn and you're trying to hit a precise target, you want to make sure you get your burn right. So split that in half and start before the clock hits 0 and after the clock hits 0. That's when you stop. That'll make more sense as we go along, though. Okay, so let me click this away. So to get rid of the flight plan that I've made, I just simply click the X here, or even on the map here, the IX. Oh, no, just close it. Okay, so press that. So what I want to do, so we're going to the moon, so I want to make sure that I select the moon. So I click on the moon and set as target. Now the first thing you're going to see here is 2 arrows. It says ascending node and descending node. So what that's showing me is in comparison to the angle that I'm currently at, I'm going pretty much east around Kerbin, but the moon does not fully match the equator of Kerbin. Okay, so it's going at a slightly different angle, and you can see here, for example, there's another moon. It's called Minmus. Here you can't really see it with the moon because it's very similar to Kerbin. But if you look at the orbit of this one out here, this line out here, so if I kind of look around it, you see that it's going a completely different angle in comparison to Kerbin. The moon's not as bad, but it still has an angle, and we want to match that because it makes things simpler when you approach it. Okay, because when you then, like, if you don't change the angle, when you then reach the moon, instead of your orbit being around the equator, you might end up with an orbit that's going around it like this, so in a different angle. If that's what you're planning, if that's the mission that you're doing, then sure, you can hit it with a different angle, and you will have to at certain points. But in this case, I just want to get around the equator of the moon, so I'm going to change my flight plan, or change my flight slightly. And the way I'll do this is I will go to one of these nodes. So in this case, I'll go to the ascending node and click right above it to create a new flight plan. Okay, and I'll add maneuver. Now to change this, to change the angle of your trajectory, that's what these are for, so the pink ones here. The easiest way for me to do it, so I've got an angle of 1.8 degrees difference. So if I just pull on this, so the descending node, oh sorry, it's the ascending node, so I'll pull the other way. Right, is that one? Fidget around a bit. Yeah, you'll see this start moving, and what you want is both of these to go towards the side. Rather be in the middle, you want them to be on both sides, like so. That's good enough. And then if I hover over it, it says ascending node, even descending node. It'll be the same number. It says 0.0. Okay, so I know then if I do this acceleration that I've set for myself, it will put me in the exact same angle as the body that I'm trying to approach. In this case, as I said, so I've selected the moon, so it's matching the moon's angle. Okay, so if I now look at my nav ball, I can see a little arrow here, and that's telling me where to go. So I've set a target for myself, and I'll just move my ship until it hits that target. Now you can see it's within this triangle. That's because that's exactly what we've used. We're using this triangle to choose our flight plan, and so that's the direction we'll be pointing in. And so I just go over the blue target marker, which in this case is over the triangle. It doesn't have to be. Like if you're picking a different target, if I was accelerating at the same time, this target would be somewhere else. But in this case, it is facing the same direction as this triangle. So I'm going to aim downwards, and I can see my node is in 4 minutes and 25 seconds. And I have to do 72.4 meters per second, and it's giving me a burn time of 2 seconds to complete this. Okay, so what I'll do though, what I can do is, so you see a button here, it's that allows me to speed up time, and it'll take me to t minus 1 minute before the node, roughly. So I'll accelerate time for now. Make sure that you adjust your ship to where it has to be, because that 1 minute you can make adjustments, but if you've got a ship that's really heavy and it takes a long time to turn, you don't want to miss your nodes. In this case, it would be the end of the world because I just have to go around the Earth again, or around Kerbin again, to get to that node again. But if you're, for example, out in space and you need to do a burn that fixes your trajectory or something like that, and you miss it, you might not have another option. You might just end up then floating into space. So in this case, I'm going to skip, and well, yeah, skip, and it'll speed up, and it'll give me 1 minute before I reach that node. Okay, so all my adjustments have been made. Don't have to do anything else. I'm not going to go full throttle because 72 meters per second isn't much. So I'll have that done within very limited amount of fuel. So I'm going to accelerate a bit. So I've got a burn time of 2 seconds, meaning I will start at t minus 1 second and burn all the way through to t plus 1 second ish. So like always make sure you take your burn time, cut that in half, and then you whatever it, so like if it's if it's 20 seconds, 10 seconds before the node, that's when you want to start your burn, until 10 seconds after, to make sure that you match the trajectory that you've calculated with your flight planning. Okay, 3, 2, 1, accelerate. And done. Let's see, so I close my flight plan off, because while the flight plan's still on, it will show me what I wanted to do. Now that I've removed it, if I hover over this, I'll see if I managed to reach what I wanted. I did indeed, so ascending node is 0.0, so I've reached the degree, so I've got the same angle as the Mun exactly. Otherwise, if I was trying to reach the Mun and I had a completely different angle, the only 2 points I'd actually be able to reach it with the angle I was using are either that point and that point. Okay, so the way I've set it now, I can try and reach the Mun here, here, here. It doesn't matter. I'll be able to reach it because it's flying at the same angle as it. If it was a completely different angle that I wouldn't be able to reach otherwise, the only 2 points I'd be able to reach it would be this one and this one in this case. Okay, now that I've done that, the next thing that I want to be doing is I'll want to accelerate towards the Mun. Now, as we are moving, the Mun is moving around the planet as well. Okay, so that's moving fast enough. So rather than when I'm accelerating, I don't want to try and aim at the Mun here. I'll have to expect it to be somewhere else. So it'll be further along its orbit. Now through experience, I know it'll probably be around about here by the time I try and accelerate towards it. So what I do is I'll create my flight plan, and what I want to do is I'll want to accelerate around it in such a way, so I want to add speeds, and just from experience I know that approximately, usually when you launch your rocket, so if you're flying your rocket and you start seeing the Mun pop out here slightly, that's the point in time that you want to start accelerating towards the Mun. Okay, and so let's say you see the Earth here, you'll be seeing the Mun, but the Mun will be over here somewhere at that point in time when I accelerate. So I know it'll probably round about, let me guess, round about here. Okay, so I'll add my maneuver here. And then I pick, so the buttons that you see here is the acceleration and the deceleration compared to the orbit that I'm in. What I want to do, I don't want to, I've already changed my height, or my angle. So all I want to do now is click the acceleration button, or direction if I was accelerating, and see if it allows me to reach the Mun. So keep going. Okay, and so now here you see a little symbol, and that shows me closest approach. Closest approach to the Mun compared to where I am. So what this is showing me now, so at the time when if I accelerate and go around here, to get to all the way up to my apoapsis that I've set would take me 8 hours. Okay, so it's a long trip that I've got, and the way it's set at the moment. So looking at the symbol, it says closest approach. What that means is, so this is where I'll be when the Mun's over here. So as you can see, I'm way too far behind to even reach it. This is when I'm at 3 hours of my trip. Apoapsis is at 8 hours. So the Mun is quite a good distance away. Actually, it's 5 million kilometers away at this point. No, sorry, 5,000 kilometers. Sorry, yeah. Okay, so I want to get much closer than that. So what I'll simply do is I'll take the node. You can pick the node from the middle, and you can just start turning it. Because I know the Mun is going to end up further over here probably by the time I reach it. So I'll keep turning, and you'll then see that my approach is getting closer. And at this point in time, it's now showing this symbol here, and that's the Mun encounter. What that means is when I reach this point, I will then no longer be in the gravity, or I'll no longer be in the gravitational forces of the planet Kerbal. I'll be then in the gravitational forces of the Mun. Okay, so once I reach this point, I'll be, yeah, it's the moon that's pulling me then. The moon, whatever. And here it shows me my periapsis, so that shows me the distance, my shortest or my longest distance from the moon, or my shortest distance. In this case, it's still 1.7 million kilometers or meters. It's confusing. So I want to make sure I get closer than that. So what I'll do is I'll continue to adjust this a bit, go further right around the planet until my periapsis reaches something that sounds better. 11's not bad. 11's a bit close maybe, but not bad. What's that now? Yeah, it's staying at 11. That's fine. Okay, so I'll keep my periapsis at 11. Actually, no, I don't want quite as close as that. 144, that's too far away. 86, that's too far away. I want to be a bit closer than that. No, that's hitting the moon. You just have to adjust it until you get what you want. So 35, yeah, that's alright. Okay, so now that I've set that, all I have to do now is wait for my for the lunar orbiter to get around to this node, and then I'll launch, and it should bring me to, yeah, if I do it right, then my calculation should bring me to where I've planned to go. Get myself a bit closer, come on, give me a nice, I want to get about 20,000 maybe. 13 is not bad. Just it slightly. 16 sounds good. I don't want to get too close because that when it says 16 or 11 something like that, that's above sea level. I know the Mun doesn't actually have a sea, but there is a sea level measured, and some parts of the Mun, I can't remember the highest point, but they do reach about 8 or 9 or 10. So I don't want to get too close. I don't want to end up ramming into the planet. Okay, so now all I have to do is wait till I reach this point, and then I'll launch for the Mun. So again, if you look at the on the nav, I see a little arrow here, and it's pointing towards the direction I want to go. In this case, it's this marker here, so it's always the blue marker. Now, as you can see, the symbol here, that's usually the symbol that we see for decelerating. So if we're trying to slow down, that's only showing at the moment because we're on the opposite side of Kerbal. Our target isn't until around the other side, so once we get around there, this will have flipped, because at the moment, if I was to accelerate in that direction, it would actually slow me down or bring me back to Kerbal. So I'm just putting it on there for now, and by the time we reach the node, this symbol will have turned around because I'll actually be on the other side of Kerbal. Okay, so what I'll do again, I will speed time up until I reach all the way around to the node that I want to go for. As you can see, yeah, the planet's turning, so also are the symbols. Because if you remember when we placed the node, it was this one we used, so it will pretty much be exactly on this at the time of our launch. Okay, moving back to this marker here. It's got 1 minute away, 21-second burn, meaning I'll want to half that, so it's about 10 seconds. So I'll want to start at T minus 10 seconds with my launch to make sure that I hit the maneuver correctly. If I was to start at 0, then I'd be burning for 20 seconds, and the burn might be slightly off, and it will take me in a slightly different trajectory, or it won't reach the moon as I've planned to do so. Again, with shorter targets with like the Mun, it's not the end of the world. You'll just have to make a few adjustments. But if you're going for something like Mars or Jupiter or any of these planets that are quite far out, you'll end up missing your target by quite a distance, and you'll have to make adjustments. And you don't want to start making adjustments when it's a long distance trip like that, especially if your burn time. Oh, I've completely missed my burn time. Talking about too much, but it should be okay. But yeah, if it's a bigger burn time, if you're looking at a burn time of 3 minutes or something like that, you don't want to miss that window. You want to make sure that you burn half the time that you want to be burning for half the time. And stop. Okay. Right, okay, let's have a look. So I removed the flight planner to make sure, so I can see if the numbers are correct. What have I ended up? I've on at 631. That's probably because my burn was that few seconds late. It's changed it by that much. If I accelerate towards, it should get me closer. That's what I mean. You want to make sure that you definitely get your burn timing right, because now I have to make a few adjustments. It's not major. I still have to make adjustments, which is going to cost me a little bit extra fuel, but not much. 48,000, 29, 17, 11. Now I'm back at 11. Oh well, that's fine. If I crash, I crash. That's what I get for talking too much. I thought I had more time when I started. Oh, I meant to show that. So just before we launched, you will have noticed the moon would have just started peeking out along the side of the Earth here. Okay, and with that, we're heading for the moon. So, yeah, so our estimated time of arrival is in about 4 hours and 57 minutes. So let's just sit back and watch for 5 hours. Or not. So yeah, I'm just going to accelerate time. One thing I'm going to do is, because what can happen during that time, so if I go to my fuel count, you'll be able to see here that so I've got electric charge and stuff like that. So my electric charge at the moment is not being used, but it will be used. Like the SAS means that your pilot is controlling the ship the whole time and holding it steady. So that can cost electricity, and when you start speeding up your time, you can end up burning through all your charge. That's something you don't want, because once you've burnt through your charge, that's it. Your ship is dead. You can't control it, you can't turn it, you can't do anything with it. So what I'm going to do, you can do this with the batteries as well, but for now I'm just going to do it on the crew hatch, or the crew pod. So right click, you see down here it says electric charge, and there's a play button beside it. If I press that, so it'll be the circle with the cross, like the do not entry kind of sign. That now means the battery will not be drained from the crew pod at all. I could do the same with the battery, so if I was to open this up, which technically I can leave open now because there's no more drag since we're in the atmosphere, I could also, for example, right click on the battery, turn it off, and this will no longer be depleted. Okay, so I'm going to speed up time for now. So say goodbye to Earth as we fly away. It just disappears in the background. So we're currently 50 times the speed. You can go faster as well, but always make sure that you don't go too fast, because you do not want to miss any of the points that you're trying to reach. It can cause you a lot of problems, and you might have to restart the mission. One thing you can do as well is make sure that you quick save. I think to quick save though, you have to be in normal speed, not mistaken. Not sure if that's saved or not. Usually, yeah, there's a quick save option. Can I do it here? Nope. Oh well. Okay, so I'll speed up my time. So yeah, always make sure you quick save, because otherwise you have to start the mission from all over again, which isn't the end of the world necessarily, but sometimes in a mission, if you've been playing a mission for a few hours already, you don't want to have to start from the beginning again. Like going to one of the other planets or something like that, that takes a lot of time, a lot of planning. You don't want that to happen. You don't want to miss that time. Oh, we're going to see a solar eclipse. That's pretty cool. Nice show you the dark side of Kerbal. Almost looks like a black hole. Right, where's the moon? Now we're getting closer. That's pretty nice. And I'm sure there's a button to get rid of all the on-screen buttons, but I'm not going to press anything for now in case I break the game. I'm too committed at this point. And there's the sun again. Woohoo! Very nice. Okay, we're getting closer to the moon. As we can see, this is the point of the moon encounter. What will happen is, because I've got the speed, the time, I've warped the speed over time. Once I reach the encounter, this will slow down again slightly. All that's letting me know, so when I reach the encounter, all that's letting me know is now that I'm in the gravitational force or gravitational pull of the moon. See, so even like you can see, there's a change now, and it's showing me that, yeah, this is my shape around the moon at the moment. What I want to be doing is I want to try and get an orbit around the moon, because I don't like, if I left it as it is, eventually I'd leave the moon's gravity and it will take me along this course, which will end up making me escape Kerbal, which will then send me to outer space. In this case, it'd just be slightly off the movement of Earth. So these are the closest planets that we have. So there, we've got Kerbal, we've got Eve, which is basically the same thing as Venus, Moho, which would be Mercury, and then you've got Duna, which would be Mars. And you've got less planets in this solar system than in real life, but to be honest, it's all you need. It's because every planet, not every planet, but planets also have moons, so there's a lot to explore. Getting there is really difficult, as it is already anyway. As you can see, the different orbits have different shapes in comparison to Kerbal's movement. So that's where the declining and that's where the nodes have to change. So that's where you change your percentage and angle. But we're getting ahead of ourselves here. Right, let me zoom back in. So what I want to do is I want to use a burn to get around the moon. I want to start an orbit around the moon so that eventually I can get back to Kerbal. So what I'll do is I just click on the periapsis, or around the periapsis, because that's the point where I want to start making the burn, because it's the most efficient place to do it as such. Right, I'll add maneuver, and because I'm passing it, I don't want to accelerate anymore. I want to decelerate. I want to start slowing down. So I'll accelerate in the opposite direction. So I'll pull that until it starts giving me an orbit around the moon. And here it shows me how much power I'll need for that. And it's expecting a burn time of 3 seconds. Let's do it like that. So get a bit closer. 4-second burn. 5-second burn. Yeah, something like that. That's fine. Don't need to get too close to the moon. Because I'm close on this side, 11,000, so I'll see enough. I'll be close enough. So I'll just do it like that for now. So I've got an orbit around the moon. That'll give me the safety to be able to go back home. Okay, let's have a quick look what we're seeing. Jebediah is loving it. He's having a great time. Right, so let's get ourselves a bit closer to the moon. I'm going to manually accelerate. I could also again click on the node, or click on this, so it'll bring me 1 minute towards it. But I want you guys to see a bit of the moon as well while we pass it, because it's so pretty. This is the actual speed that we're doing. It's quite slow in comparison. So when you speed up, it just feels like you're getting launched towards, but no, that's not the real speed. That's 50 times the speed of what we're actually flying. Now, as we get closer, the camera will turn slightly. Go into orbit mode, does it automatically. You can change the camera any time if you want to, but I generally keep it as it is. I like the way the game's set. Okay, so I've turned around to match the target that I'm going for. And my node is in 5 minutes. Burn time 4 seconds, so half that, which is 2 seconds. So at t minus 2 seconds, I will be starting my burn around the moon. Oh, see, there we go. There the camera turned on us because we're getting close to orbit. 96,000 meters above. Going to get quite close. So what's it telling us? We're going to be reaching 11,000. So approximately the same height as a commercial airliner would fly above Earth. So yeah, close enough. Considering it's our Kerbal's first attempt at reaching the moon, that's not bad. Okay, what we'll be doing once we get closer. So we could have done it like when space far above Kerbal. We could have done some sciencey things, or far above the moon we could have done it. But I'm waiting now till we get close to the moon to do experiments, because that will give us the most science points. Because the further you're out and the more science you're collecting from objects that are far away from Kerbal, that gives you more points. So in this case, actually I've got two. Actually, I could do it. So I can do it here. So right click on this, log my pressure data. That gives me 24 science. Instrument reads 0 if it was in a vacuum. So 24 science, like back on Kerbal, I would only got 3.5 for this exact same experiment. So I'll keep that. That's pretty good. My thermal, log temperature, 16 for that. Pretty good as well. Let's do my mystery goo. That gives me 30 science. Great. Now, these three, as you can see, these three that I've done, review the data, give me. Oh, I'm already near the Mun already. Okay, so that's for near the Mun. Was that one for near the Mun as well? Review data. That was high in space, so I just passed the I think it's at 60,000. When you reach 60,000, it goes from high in space, or high in space, high over the body, to near. So what I'm going to do, so I'll reset that one, and I'll let these all be the near. So it's 36 data. That's pretty good. 36, and log this one as well. I'll write that for now. It's 24. It's pretty good. So yeah, you've got near space, and you've got near the object in space, and far from the object in space. Now near will give you more science points. So I'll wait for these three experiments till we're far away again. So when we're above 60,000. What I will be doing is this one here, the Science Junior. That should give me a good amount of points. 75 science. That's excellent. That'll give me so much availability for back home. And finally, I will do a crew report. That gives me 15 science. Not that much, but it's still good. More than with all our science gadgets back on Earth. Jebediah is loving it. Loving every moment. Can't blame him. Now usually, I haven't unlocked it yet because this is something you have to unlock in one of the, I think it's in the astronaut complex. It gives you the option to EVA. We've done that in the previous video on land, but if we want to do it in space, you have to, yeah, it even says it there, astronaut complex, upgrade required. But we'll get to that later at a later stage. EVA missions allow, well, EVA stuff allows you to get extra science points as well, because you can give a crew report from outside, or as a scientist you can reset all these experiments, because this experiment, for example, has to be reset, as does the mystery goo. And any of these as well, you can collect the science and take it back into the main ship. So for example, if you decided you don't, when you're coming back home and you don't want to bring all this back with you, you can leave it up in space and just go back in your crew pod, because it's easier to land with a crew pod. You could bring your science, or you could remove all the science from this and take it into the crew pod, as you've seen in the previous video if you watched it. Okay, node in 55 seconds. Let's make sure I don't miss it this time, because this one would be crucial, or this one is crucial. "42 seconds, I'm going to fast forward slightly. There we go, so 4-second burn, so at T-2 I shall start. There we go. Now speed's going down, and boom, done. Okay, so there's my orbit. You can still see the flight path that I created, so I want to remove that so I can see the actual flight path that I've ended up with. And it was, pretty much on the ball. On the ball for what I was expecting to do. A quick look outside, because we're at the closest point of the moon. Oh, the sun's about to disappear on this side as well. Pretty nice. See, we're not that far off. Pretty close. Closer than any of us will ever get. And there the sun disappears. Right, okay, just for the sake of this video, because usually I could go around the moon a few times, enjoy the view, but I'm just going to bring us home for now. And to do so what I want to do is, when I look at the moon's orbit, so the moon is heading around Kerbin this way around, okay? And the easiest way for me to get back is from the orbit, accelerate in such a way that I end up pointing backwards of where the moon is heading. That will give me the best trajectory to get back to Kerbin. So the way I'll do that is, let's have a quick look. Battery power still fine. So I will, let me guess, I'll start at the apoapsis, and from there add a maneuver where I start accelerating. Even though accelerating, what I'm doing is I'm accelerating in the opposite direction where the moon is going, so it will slow me down in comparison to the moon's orbit, or the moon's gravity force, because I want to get back into Kerbin's gravity force. So let me start accelerating in this direction, and as you see this line over here, that what it's letting me know is, because here it's showing this is the moon's escape, and then at that point it will be take me back into Kerbin's gravity influence. And as I mentioned, the best way to reach it is if I actually aim as close to that line as possible, roughly. So my periapsis around Kerbin at the moment is 2.5 million and 9 million. So I want to get closer than that. So maybe a bit more acceleration. I'll click on that. Acceleration. Nah, maybe not, a bit less, and move my node to about there. Let's see what we've got there. 1.8 million, more acceleration. 1.4. That's the good thing about the flight node. You can just play around to figure it out. Like I kind of know, I roughly know what I'm doing because I've done it a few times, but like if you're a new player, it doesn't matter, because in this case this node is 1 hour and 1 minute away, so I've got a full hour to try and figure out what I'm trying to do. That's why you always want to make sure you don't plan your flights when you get close to it. You plan them as soon as possible so you can get around the planet, or get around your object. Yeah, so do it as soon as possible so that you've got the time to fix any errors. Okay, what's that? 700,000. I'm getting closer. Accelerate a bit more. Where does that bring me? 197. More like that. 11,000. Okay, that's too low. I don't want to get as low as that. 61 could be alright. What if I do a bit more speed than that? A bit more speed will allow me to 18. I don't want to get quite as low as that. I don't want to damage my ship. It could possibly work with a heat shield, but I've had bad experience. If you enter, like, because what's going to happen is we're going to enter Kerbin with a high speed. We're probably going to enter Kerbin with a speed of 3,000 meters per second. Now that's quite high. The previous times when we've came back from orbit, it's been about 2,200 or slowed down to 2,000 before we've reached the atmosphere, and you can still see the ship is burning. With a heat shield it shouldn't matter, but at the same time I don't want to get too low because I don't want to be so fast that I'm going to end up crashing. So I'm just going to try for now to get maybe to about, let's see, about 30,000. Because you've got to imagine, like, so even when I hit this, my speed is going to be that much that it will take me all the way back up to here. I don't want all that speed. I want to lose as much speed as I can. And what you can do, like, if you like, so what I'll be doing is I'll be going into the atmosphere, and the atmosphere will allow me to slow down. And it'll let me slow down quite a bit. So even this higher apoapsis will drop while I'm in the atmosphere because the drag will slow me down. So for example, if you know you only have enough fuel to just barely reach a periapsis in the or reach the atmosphere, you can always use the atmosphere to slow you down. So if you can reach 65, for example, or you preferably lower, but if you can reach below space, you can get slowed down enough that eventually this will drop and drop and drop and drop until you reach the height that you can re-enter Kerbin. So if you notice, for example, oh, I don't have enough fuel to slow myself down properly, well, as long as you can reach the atmosphere, it will slow you down enough to eventually kill off the extra trajectory or extra speed that you have. But for now, I'm going to try this. Let's get me a good height. 46, a bit lower, I prefer. 24. Yeah, I'll try that. Okay, so yeah, so that's 307 meters per second that I need to slow myself down. I've got more than enough fuel. I mean, that's a burn of 6 seconds. I think I've got probably about 12 seconds burn here, so I could definitely slow myself down with that. Okay, so what I do now is position myself, as always, put myself in the right position, and I will skip. So 6 second burn means I'll be launching T minus 3 seconds into 3 seconds above. Or T plus 3 seconds. Just to mention as well, the burn time is only applicable to the engine that you have set at the moment and the weight of the ship. Now, if you, for example, if I still had the back part that I had earlier and I used this, the burn time will change because it's literally just working out the speed with the current engine, the current weight you have. Okay, so once you decouple, it changes things. Like the time can be less, most likely less, depending on the engine you've got. Alright, 3 seconds and burn. Stop. Oh, I'm slightly off target. Let's go here and slowly burn. Okay, let me just quickly check. I will remove my flight plan and let's see how far we actually are away. 40,000, it's a bit high, so I'm going to continue along the line that I'm going and shrink that even more. 20,000, yeah, 20,000 is quite low. Yeah, I'll stick with that. Hopefully it'll work. We might end up burning up in the atmosphere, but, well, that's what this game's about. It's trial and error. We'll see what happens. Okay, and for the sake of time, I'm just going to skip. Oh, just remembered one thing that I wanted to do beforehand. Was complete the other experiments just for the extra points. Log pressure data, 24. Mystery goo, 20. So that actually gives me less. Huh. And the thermometer, 16. I actually thought the mystery goo might have given me more than that, but oh no, yeah, I unlocked that later on. Maybe that's why. That's fine. Okay, and for now, to make sure I don't burn any unnecessary battery, because I'm going to speed the things up. I think I have one of them turned off already, unless I turn it back on. That's on. Oh, they're both on. So I'm going to turn one of them off, so I have definitely enough battery power. Last thing you want is running out of battery power. I don't need it for anything. There's no such thing in the game as life support, as such. So you don't require battery for your Kerbal to survive. I think you've even got the option of turning your lights on. I don't actually think that burns any energy. That's not something they've added. There is mods that will allow you to have life support with food, waste disposal, water, CO2, all those things, oxygen. But the standard vanilla version doesn't have that. So once you turn the battery off, you don't have to worry about your Kerbal dying. So I'll just do it for now. And yeah, we'll speed things up. Before I do so, I will close this over. And close this, because once we hit the atmosphere, that could cause damage. Okay, and speed it up. Warp the time. See, time slowed down. What that's letting me know is I'm now back in the... Oh, flip the whole camera. It's now letting me know that I'm back in the orbit of, or in the gravitational pull of in this case, carbon. But in the gravitational pull of the said object that you're heading for. And it's turned the camera in a very weird way. I think that's because it's seeing it as an orbit. An orbital approach. Okay. Let me speed time up a bit. Oh, not too much. And I want to position myself in such a way that I start slowing down. I'm in here. See, it says I don't have enough fuel. I have enough fuel to slow me down that much to reach an apoapsis of 2 million. But while I'm hitting the atmosphere, it'll slow me down as well. I will probably start the burn way sooner than what I've marked, just so that I know approximately. But yeah, once I'm inside the atmosphere of Kerbin, the drag will slow me down as well, like the drag of the air. I hope I'm not going to be too fast and end up burning up. We'll see. Regardless, I will be posting this video. Not that you'd know if I hadn't said that, but I will be posting this anyway, just so you can see what happens, what can happen. Okay, the camera is really confusing me, but okay. Alright, let me start positioning my ship though, so that, oops, when we do go in the atmosphere, that we're ready. This video is actually ending up being longer than intended, but there's a lot to explain, I guess. Actually, I'm going to change the camera because, oh, that's not how I do it. What was it? Orbital camera. Yeah, I don't want the the camera. I want to be around there this way. I think the other one's... Yeah, just leave it orbital for now. Okay, so I'm going to try and get closer. I will speed up, well, I'll speed up manually. Good thing is, again, the good thing is, the closer I get to a planet or to a body in space, whatever, even if I'm at 100,000 times speed, it will slow down automatically. Don't always trust it, but it usually will slow down because it will only allow you to do a certain speed around an object. See, it's already changed there itself. Oh, we're getting very close indeed. Okay, that's me inside. Very, very high speed, so I'm instantly going to slow myself down. Not a speed I want to be at. Oh, is that all the burn I had left? Okay. Get rid of the engine. Hopefully I'll be able to slow down. Yeah, it's going to cause quite a bit of damage. Ablator's burning quite a bit. I might actually be okay. Ooh, nope. See, this signal here is a temperature gauge. What it's telling me is, yeah, that it's not going well. Oh shit. Yeah, I've came in at way too high of a speed. Nope, that's not good. That is not good. Not good at all. So if I do survive this, it's going to be pure luck. But I've lost some of my science, so that 75 science that I had is gone. Is that burnt up? Oh, I'm flying like a bullet. So I can't even open my drogue parachutes yet because I'm way too fast. Hopefully I'll slow down enough in just a moment. Maybe not. Oh, this is not good. So what this means is I've came in at way too steep of an angle. Now I can open my chutes. Slow myself down. Okay. Oh, my other ship. Speed up time. Well, that's a bit annoying, but hey, it's a part of the game. Landed. Recover vessel. Okay, so I've got quite a lot of science out though. I've got 181 still. I miss out on the 75 from the junior, which is a bit of a shame. But still, that's a lot of science. Very useful for next time going to the moon. I can do so much. I can buy so much extra things. Recovered some funds. Didn't get any reputation points for that. Alright, well, at least I gained some XP. That's good. And a few milestones as well. World first milestones, so speed records, fly by the moon, gravitational influence of Kerbin. So we escaped that. So we got quite a few things. Got a bit of money, quite a lot of money actually. So that mission gave us about 350,000's worth, which is excellent. A lot of reputation, a lot of science points extras as well, so that's pretty good. Mission complete, mission complete, mission complete. Yeah, that's giving us a lot. So for the next video, we'll have a lot of points, be able to do a lot more stuff. Right, see you then.